Google just quietly announced something that could completely reshape how we think about computing forever. While everyone was distracted by the latest AI drama, quantum computing just took a leap that most experts thought was still years away. The implications of what happened last week are so massive that even seasoned tech veterans are scrambling to understand what this means for the future of everything, from cryptocurrency to artificial intelligence. Here's what you need to know. Traditional computers process information using bits that are either 0 or 1. Think of it like a light switch that's either on or off. Quantum computing changes this entire game by using quantum bits, or qubits, that can exist in multiple states simultaneously. Imagine a coin that's spinning in the air, being both heads and tails at the same time, until it lands. That's the basic principle behind quantum mechanics that makes these machines so powerful. But here's where things get really interesting. For decades, quantum computers have been plagued by a fundamental problem called quantum error correction. These machines are incredibly sensitive to environmental interference. Even the slightest vibration, temperature change, or electromagnetic field can cause errors that make the calculations unreliable. It's like trying to perform surgery during an earthquake while wearing oven mitts. The breakthrough that just happened addresses this core challenge in a way nobody saw coming. Researchers have developed a new approach to quantum error correction that doesn't just fix the problem, it actually uses the errors as part of the computation process. Instead of fighting against quantum decoherence, they've learned to harness it. This is like discovering that the static on your radio can actually help you hear the music more clearly. Most people don't realize how close we were to hitting a wall with classical computing. Moore's law, which predicted that computer processing power would double every 2 years, has been slowing down significantly. We're approaching the physical limits of how small we can make transistors. Silicon atoms are only so big, and quantum effects start interfering with normal computer operations at extremely small scales. Traditional computing is running out of room to grow. This quantum computing advancement changes everything because it opens up computational possibilities that are literally impossible with classical computers. Problems that would take the world's most powerful supercomputers millions of years to solve could potentially be solved in minutes or hours. We're talking about simulating complex molecular interactions for drug discovery, optimizing global supply chains in real time, and breaking encryption methods that currently protect our entire digital infrastructure. Let me give you a concrete example of what this means. Right now, developing new medications involves years of trial and error because we can't accurately simulate how drugs will interact with complex biological systems. With quantum computing, researchers could model these interactions at the molecular level with unprecedented accuracy. This could compress drug development timelines from decades to just a few years, potentially saving millions of lives and billions of dollars. The financial implications are staggering. Investment firms are already pouring money into quantum computing startups, and the market predictions are almost hard to believe. Some analysts estimate that quantum computing could create a $1 trillion market within the next 15 years. Companies that get ahead of this curve early could dominate entire industries, while those that ignore it might find themselves completely obsolete. But here's what really keeps security experts awake at night. Current encryption methods rely on the fact that certain mathematical problems are virtually impossible for classical computers to solve in a reasonable time frame. Quantum computers could crack these encryption methods like they're opening a simple padlock. This means that almost every secure communication system we use today, from online banking to military communications, could become vulnerable overnight. The race is already on to develop quantum-resistant encryption methods. Governments and corporations are investing billions in post-quantum cryptography research. The National Institute of Standards and Technology has been working on new encryption standards specifically designed to withstand quantum attacks. This isn't just about protecting data, it's about maintaining the foundation of trust that our entire digital economy depends on. Now, before you start panicking about quantum computers taking over tomorrow, let's talk about the current limitations. These machines still require extremely controlled environments to operate. We're talking about temperatures colder than outer space, and isolation from virtually all electromagnetic interference. The quantum computers that exist today are more like delicate laboratory experiments than practical computing devices. The cost barrier is also enormous right now. Building and maintaining a quantum computer costs millions of dollars and requires teams of specialized scientists and engineers. The machines themselves are typically the size of entire rooms and need constant maintenance when we're nowhere near having quantum laptops or quantum smartphones, and we might never get there using current technology approaches. However, cloud-based quantum computing is already changing the accessibility equation. Companies like IBM, Google, and Amazon are offering quantum computing resources through their cloud platforms. This means that smaller companies and research institutions can experiment with quantum algorithms without building their own multi-million-dollar machines. It's similar to how cloud computing democratized access to powerful traditional computing resources. The timeline for widespread quantum computing adoption is still uncertain, but the momentum is undeniable. Major tech companies are hiring quantum computing experts at unprecedented rates. Universities are launching new quantum computing programs. Venture capital firms are creating dedicated quantum computing investment funds. All the signs point to an industry that's preparing for a major transformation. For individual investors and tech enthusiasts, this creates both opportunities and challenges. Understanding quantum computing could become as important as understanding the internet was in the 1990s. Companies that successfully integrate quantum computing into their operations could see massive competitive advantages. But predicting which specific companies will succeed is incredibly difficult at this early stage. The job market implications are fascinating to consider. Quantum computing will likely create entirely new categories of employment, while making others obsolete. We'll need quantum software engineers, quantum algorithm designers, and quantum system administrators. Traditional cybersecurity roles will need to evolve to address quantum threats. Educational institutions are scrambling to develop curricula that prepare students for this quantum future. Here's something most people miss about this quantum computing revolution. It's not just about raw computational power. Quantum computers could enable entirely new approaches to machine learning and artificial intelligence. Quantum machine learning algorithms could identify patterns and relationships in data that are completely invisible to classical AI systems. This could accelerate AI development in unexpected directions. The environmental impact is another crucial consideration. Current quantum computers require enormous amounts of energy to maintain their ultra-low operating temperatures. However, if quantum computing can solve optimization problems more efficiently than classical computers, the net environmental benefit could be substantial. Better supply chain optimization, more efficient energy distribution, and improved materials science could all contribute to sustainability efforts. Looking ahead, the next few years will be critical for quantum computing development. We're likely to see continued improvements in quantum error correction, longer coherence times, and more stable qubits. The race between different quantum computing approaches, including superconducting circuits, trapped ions, and photonic systems, will determine which technologies ultimately prevail. The geopolitical implications cannot be ignored either. Quantum computing represents a potential source of significant national advantage. Countries that lead in quantum technology could dominate everything from cryptography to scientific research. This has led to substantial government investment programs and export restrictions on quantum computing technology. So, what does all this mean for you right now? First, stay informed about quantum computing developments because they will affect multiple aspects of technology and society. Second, consider how quantum computing might impact your industry or career path. Third, be cautious about quantum computing investment opportunities, as this field is still highly speculative and risky. The quantum computing revolution is just beginning, but the changes it brings will be profound and permanent. We're witnessing the early stages of a transformation that could be as significant as the transition from mechanical calculation to electronic computers. The companies, countries, and individuals who understand and prepare for this quantum future will have tremendous advantages over those who don't. If this breakdown of quantum computing's game-changing potential was helpful, Hit that like button and subscribe for more deep dives into emerging technologies. What aspect of quantum computing do you think will have the biggest impact on society? Share your thoughts in the comments below. Next time, we'll explore how artificial intelligence and quantum computing might converge to create capabilities that sound like science fiction today.